Hey guys, it's Miss Severi. I hope you're all doing great. We made it to week 4 of our emergency learning plan, and we are still going to talk about probability. So last week we learned theoretical and experimental. So theoretical, in theory, this is what should happen. Experimental, remember you have to conduct the experiment and then you calculate those results. So last week, I went ahead and used this spinner as an example. So the theoretical probability of getting green was 2 spaces out of the 5. But when I conducted the experiment, down here I did 10 trials, I got green 3 times out of the 10 times that I spun. So you can see that these don't match. I didn't get blue at all, and in theory I should have gotten blue 20% of the time. So why don't these match? And then will they ever match? So this is what we're going to talk about today. So we're going to talk about the law of large numbers, and I'm going to start off with this video.
Stay right where you are. It's Highway Chase for real. Just in time. I really don't like it when I miss the start of the movie. There were 2 films I really wanted to see. One is this new dinosaur movie, and the other stars Giovanni, my favorite actor. So when I got to the box office, I don't know which one to pick. I'll flip a coin. Heads, dinosaurs. Tails, Giovanni. Heads. I wonder what'll happen if I try that again. Heads. Again? Heads. It doesn't seem fair. Poor Giovanni didn't come up once. Is this fair? Even Steven, 50-50? Finally. But that's 3 heads to 1 tail. Doesn't seem fair. So I decided I wanted to do some research on why Giovanni didn't win half the time. Fred's Encyclopedia of Probability. Let's see. 1 in a million, 1 in 1,000, 1 in 100. Here we go. 50-50. When flipping a fair coin, about half the time it will be heads and about half the time tails. See note. See note. Note. This will only happen if you flip the coin many times. Well, I flipped the coin 4 times, but I got 3 heads to 1 tail, and that's not half and half. You have to flip a lot more than 4 times. Hey, do you remember I asked you to hold my plate? Yes. Okay, great. Thanks. Wait a minute! Flipping 10 coins 1 time is the same as flipping 1 coin 10 times. Excuse me. I'm trying to find out if I flip a coin a lot of times, will the results really be 50-50? Heads about half the time and tails about half. Will you help me? Come on, it'll only take a minute. How many heads? Raise your hands. Only 3 heads and 7 tails. With 10 coin flips, that's still not very close to 50-50. I need to try this with a lot more people. This better work. Can I borrow that for a second? Sure. Thank you. Hello? I need everyone to flip a coin to see if heads really does come up about half the time. Just the people who got heads, raise your hands. How many people here?
350 paid at the gate.
Wow, then it is true. I think I could say that's pretty much 50-50. Thanks. Fred's Encyclopedia was right. If you flip a coin just a few times, it might not be close to 50-50. But if you flip lots of times, like 350, then it will be closer to heads about half the time and tails about half.
Okay, so what does that mean for us? Basically, the law of large numbers tells us the more trials we do, the closer to the theoretical probability you will get. So no, we are talking about a lot of trials. Remember, if you just do it one time or 10 times, you're not going to get close to that theoretical probability. But if you do it hundreds or thousands and thousands of times, you should get close to your theoretical probability. So here's an example problem. It says Zach conducted a probability experiment by flipping a coin 300 times. He recorded the results below. He got 100 heads and 200 tails. So even though this experiment was done 300 times, we did not get our expected results of 50-50. But what if he flips the coin an additional 1,000 times? What should happen? So, will the experimental probability move farther away? Will the experimental probability move closer to the theoretical probability? Does the theoretical probability begin to change? Or does the experimental probability have no chance of changing? So let's break down all four of these. So the experimental probability will move farther away. Well, we know that's not true because we know the more times we do, the closer we get. So I can eliminate answer choice A. Let's look at B. The experimental probability will move closer to the theoretical probability. This is exactly what the law of large numbers states. So I know yes, B is true. Let's look at C. The theoretical probability will begin to change. Can the theoretical probability change? No, it cannot. The theoretical probability of getting heads is 50%. That's not going to change because in theory, that's what should happen. There's no experiment being done, so the theoretical probability cannot change. So this is wrong. And then D, the experimental probability has no chance of changing as the number of trials increase. Well, wait a second. If I'm doing more trials, with every trial that I do, the probability is changing because my total number of trials has changed. So experimental probability always changes. So this is wrong. After I've eliminated my choices, I know that answer choice B is correct. The experimental probability will move closer to the theoretical probability as the number of trials increase. Okay, so when you go to your choice board, you have options on this topic. So that's all we're doing this week is the law of large numbers. My experimental probability will get closer to the theoretical as the number of trials increase. Thanks, guys.